Assalamu alaikum wa rahmatullah. In this video, we will discuss the regulation of the renal blood flow and the glomerular filtration rate. There are different mechanisms that can affect the renal blood flow and glomerular filtration rate. And as discussed in the lecture, these mechanisms may be hormonal, neural, autoregulation, or other. These mechanisms affect the afferent and efferent arterial resistance pressure to affect the glomerular filtration rate. First, we will discuss the autoregulation. Autoregulation is intrinsic mechanism of the kidney to control the glomerular filtration rate and renal blood flow with change in the blood pressure. Blood pressure is variable and widely changed during the day, and this change in the blood pressure cause increased change in hydrostatic pressure and renal plasma flow. Both of them affect the GFR. This change in the renal blood flow and the GFR with change in the blood pressure may have the undesirable effect, may cause undesired change in the excretion with decrease in very large increase of the urine, and also cause structural damage to the glomerulus from the high blood pressure. So, the autoregulation prevents this problem. In this graph, in the x-axis, there is mean arterial pressure, and in the y, there is the GFR. Mean arterial pressure at 100 mm mercury equal to 120 GFR. Blood pressure range between 80 to 170. This will control the GFR with normal limit, which is 120. Change in the blood pressure above and below this level may affect the GFR. So the autoregulation in this limit of the blood pressure. So how the autoregulation control the GFR equal or not affected by change in the blood pressure and this effect. Blood pressure, as we say, affect the GFR by glomerular hydrostatic pressure and affect the renal blood flow. The autoregulation affect the afferent arteriole by negative feedback, afferent arterial resistance pressure by negative feedback that affect the glomerular hydrostatic pressure and renal plasma flow. These autoregulation function by two parts: myogenic response and tubuloglomerular feedback. First, we discuss the myogenic response. Both of them affect the afferent arterial resistance pressure. Myogenic response is the first. It is the ability of the kidney to control the blood, to control the GFR with increasing the blood pressure. This video, this is the cross section of the afferent arteriole. In this video, we can see the smooth muscle cell. It contains special channel. With increasing blood pressure of the afferent arteriole, this afferent increasing in blood pressure causing stretching of the muscle wall. This stretching causing opening of this channel. Opening of this channel cause influx of cation. The influx of cation cause depolarization. Depolarization cause contraction. So constriction and increasing of the resistance in the afferent arteriole. So with increasing blood pressure, this causes the myogenic effect, increasing the resistance of the afferent arteriole, negative feedback on the glomerular hydrostatic pressure, and decreasing the renal blood flow. All of these causing decreasing in the GFR with normal rate. The second factor is the tubuloglomerular feedback. The same condition with increasing blood pressure, increasing the GFR, increasing the filtration, increasing the substance in the glomerular filtrate. This cause a negative feedback on the afferent arteriole. With the increasing blood pressure, more filtrate. This filtrate passing in the collecting system to reaching to the ascending loop of Helene to reaching the macula dense cell. Macula dense cell is the chemoreceptor cell that detect the level of the sodium. When there is an increase in the blood pressure, there is an increase in the filter rate, so more sodium will be detected by macula dense cell. So the macula dense cell, as we say, this chemoreceptor will detect an increased sodium will secrete different substances that affect the afferent arteriole, causing it to constrict. Constriction will decrease the renal blood flow to the glomerulus, so decreasing the GFR to the normal level in this graph. Increasing the blood pressure, also increasing the hydrostatic pressure, increasing the GFR, negative feedback till reaching the afferent arteriole, causing constriction. The constriction causing negative feedback, decreasing the glomerular hydrostatic pressure and renal blood flow. This is the tubulo-glomerular feedback. Both of these two mechanisms with the myogenic control the limit of the GFR within normal level with the change in the blood pressure, so not affect heart, not affect the body. Other function of the other mechanism is the angiotensin 2, and discussed in the lecture. It is active substance effective when decreasing the blood pressure. The angiotensin 2 causing it is part of the renin-angiotensin-aldosterone system. This active substance either act by itself, causing increased resistance of the afferent arteriole, so increasing the hydrostatic pressure. The increasing hydrostatic pressure of the afferent arteriole affecting the GFR, so decreasing the blood pressure. Sympathetic nerve, which is the neural effect. With the decreasing of the blood pressure, sympathetic effect send nerve supply both for afferent and efferent arteriole. This will cause increase the hydrostatic pressure and decrease the renal blood flow. So this will cause low sodium and water excretion, so increasing in the blood, so increasing the extracellular fluid and increasing the blood pressure. Dopamine is another factor, which is hormonal factor, also affect. Prostaglandin is also affect. Thank you.